Assalamualaikum. Today our group will present about assignment 2 for electric machine. Our group members is Muhammad Haziq bin Hasmidan, Ammar bin Ahmad Osman, Zaim Asfar bin Ibrahim, Nur Syafirul Hana binti Muhammad Roslan, and Nur Khalida Yasmin binti Kabul Yamin. Next, I will pass to Zaim to talk about guidelines and requirement of energy efficient motor.
Assalamualaikum. Thank you, Haziq, for giving me opportunities to explain a little bit about guideline and requirement for energy efficient motor based on IEE and IEC. For introduction, basically, IEC, or as known as International Electrotechnical Committee 6003430, was introduced in November 2008. The purpose of this organization is to improve the competition of the motor market transformation, as it is widely used in the industry. Electric motor consume between 30% to 40% of generated energy. The standardization of this motor is important to ensure the consumption of energy is at the normal level. For the initial stage, 3 classes was introduced. For the first, standard efficiency class IE1, IE2 high efficiency, and IE3, which is premium efficiency. In the last proposal, IE4 was introduced, and until now researchers and developers still develop the IE5 and need to be tested and experimented. IE5 estimately will reduce the energy consumption by 20% than IE4. Okay, for this time, there are 7 requirements that we emphasize to determine the classes of each motor. For the first, power output, second, pulse, third, speed, fourth, RPM frequency, fifth, temperature class, sixth, insulation class, and the lastly is protection technology. For the power output, IE1 until IE3 give the same output power, which is 0.75 kilowatt until 355 kilowatt. Except for the IE4, it produces 2.2 kilowatt until 230 kilowatt. For the pulse IE1, there is 2 or 4 or 6 or 8 or 10. For IE2 is 2 or 4 or 6. For IE3 and IE4 is the same, which is 2, 4, 6 and 8 poles. For the RPM, IE1 will produce 500 RPM until 3600. For IE2, 1000 until 3600 RPM. And for IE3 and IE4, which is the same RPM, which is 750 until 3600 RPM. For the RPM frequency, IE1 until IE4 give the same RPM frequency, which is 50 or 60 Hz. For the temperature class and the insulation class, both give the same class, which is IE1 and IE4 get B for the temperature class, and for the insulation class, IE1 until IE4 get F. For the protection technology, IE1 until IE3 have IP55, IP56, IP65, and IP66, except for the IE4 is IP55, IP56, and only IP65. Okay, I think that's all from me. We can pass to the Haziq.
Thank you, Zaim. Okay. Assalamualaikum. My name is Muhammad Haziq bin Hasmidan. I'm going to talk about general information or classification for electric motor. First, it has single speed electric motors, single and 3 phases, 50 and 60 Hz. Second, line start permanent magnet motors. Third, it has 2, 4, 6 or 8 poles. Fourth, it has rated output PN from 0.12 kilowatt to 1000 kilowatts. Fifth, rated voltage UN above 50 volt up to 1 kilovolt. And the last one is motors capable of continuous operation at their rated power with a temperature rise within the specified insulation temperature class. Okay, next I will talk about electric motor excluded by the IEC standard. The first one is motor designed to operate wholly immersed in a liquid. Second, brake motors, when the brake cannot be dismantled or separately fed. Third, single-speed motors with 10 or more poles or multi-speed motors. And the last one is motors completely integrated into a machine. For example, pump, fan that cannot be tested separately from machine. Okay, next I will pass to Nur Khalida to present about her title.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Khalida Yasmin binti Kabul Yamin. I'm gonna present about method to measure of efficiency on low voltage induction machine. The first method is IEE Standard 12. This IEE Standard 12 estimate the efficiency by the direct method where the efficiency equal to output power divided by input power. This formula also used to calculate efficiency on three-phase induction motor. The second method is IEC Standard 600342. While the first method calculates the efficiency in a direct way, this IEC Standard 600342 calculates the efficiency in indirect method, where output power is equal loss plus input power. Hence, the efficiency equal to 1 minus losses power divided by input power. The third method is NEMA MG1 12.47, where efficiency is equal to 0.7457 times horsepower times load divided by input power. This efficiency operated in percentage, where the load is equal to output power as a percentage of rated power. The constant factor 0.7457 is used to convert horsepower to kilowatts. This is because 1 horsepower is equal to 745.7 watt or 0.7457 kilowatts. Next, the rotor efficiency of three-phase induction motor, where the efficiency is equal to rotor output divided by rotor input. Last, three-phase induction motor efficiency, where the efficiency is equal to power developed at shaft divided by electrical input to the motor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad bin Ahmad Osman. I would like to explain about methods to improve the efficiency of electrical motor. The first method is regular inspection. The most common cause of motor failure is low resistance. This occurs when the insulation of the winding is degraded by adverse conditions such as overheating, corrosion, or physical damage, leading to insufficient isolation between winding, leakage, short circuit, and eventually motor failure. The second method is protect against electrical overload. Electrical overload or overcurrent occurs when the current that the motor is designed to carry efficiently and safely is exceeded. The most common cause of this is a low voltage supply, which causes the motor to draw in extra current in an attempt to maintain torque. However, it can also be caused by short-circuited conductor or an excessive voltage supply. The installation of effective overcurrent protection can detect overcurrent before it becomes a problem, interrupting supply and protecting against overload. This will enable the motor to operate at maximum efficiency. The third method is keep cool. With around 55% of insulating motor failures caused by overheating, the benefits of keeping your motor cool are clear to see. For every 10 degrees Celsius that the temperature of a motor is raised, the installation life is reduced by 50%. Ensuring that the operating environment is kept cool is the easiest way to keep the temperature of motor down. This will help to prevent breakdown, increasing the efficiency of your electric motor. Monitor vibration is one of the methods. Vibration in electric motor is commonly caused by an uneven or unstable surface. However, it can also be a result of underlying problems such as loose bearing, corrosion, or misalignment. It's important to monitor vibration level as excess vibration can cause the motor to fail prematurely. A motor analyzing tool such as SKF Enlight Quick Collide is simple, low-cost option which is ideal for monitoring the vibration level and temperature of an electric motor. This can help to ensure that the motor is able to run at full efficiency and reduce the risk of premature motor failure. Furthermore, protect against contamination is one of the methods. The main of method we know, the electric motor often operate in environments which are contaminated by dust, dirt, or chemical. However, with contamination being one of the leading causes of motor failure, it is critical to ensure that electric motors are well protected against contamination. Next, the method is using copper bars in the rotor. When it comes to rotor, copper offers the advantage of efficiency as well. Copper rotors are preferred for energy-conscious industries in developed countries and in developing nations. And the last method is more coils make motors more efficient. The wires in the phase coil of small power motors are thinner. However, the number of coils turned should be high to increase the magnet motive force or current density. That's all for the method to improve the efficiency of electric motor.
Assalamualaikum. My name is Nasha Firhana. Okay, let us see the next point, which is analyzing the cost saving and payback periods by using energy efficient motor. First is total cost saving, which is the amount of money that can be saved. It depends on the size and the annual hours used, the load factor and efficiency improvement. So this is the formula for total cost saving. Next is payback period. The payback period depends on some requirements such as the incremental or premium cost paid, which is we can get it from the table for an average efficiency and typical list prices. For a higher efficiency, the power saving of the motor and its hour operation and electricity cost. So this is the formula for payback period. Next, let's move to an example. Given 125 horsepower operating at 75% full rated load, for the first step is we need to calculate kilowatt saved, which is horsepower times load times 0.746 times 100 over standard energy rating minus 100 over energy efficient motor rating. The load is from the 75% and the 0.746 is a conversion from horsepower to kilowatt unit. So we get 2.6. Next step is energy saved, which is we can get from hours of operation time kilowatt saved, 2.6. So we get 20.8 kilowatt hours per year. The next step is annual cost saving, which is the total cost saving, equal to kilowatt saved times 12 time monthly demand charge plus kilowatt hour saving time energy charge. So we get 232 for total cost saving. And the last step is simple payback, which is price premium time discount factor divided by total annual cost saving. 2416 is we get from the table times 0.3 divided by 232, which is we get 2.1 years, which is the additional investment required to buy an energy efficient motor would be recovered within 3.1 years. Okay, that's all for our presentation. Thank you for lending us your ears.